This is Mr. Martin. These are video notes for pre-calculus honors. We're talking about section 7.3, partial fraction decomposition. For example 3, we're looking at irreducible quadratic factors. So what we mean about that is typically in a problem like this we would look at our denominator and see if we can factor it into linear factors if possible. So we have these two factors on the bottom, x plus 1 and x squared plus 2x plus 2. And x squared plus 2x plus 2 is not going to factor. And if you're ever not sure that quadratic is going to factor, what you can do is you can look at the discriminant. If you remember that from algebra, really you're just going to look at b squared minus 4ac, and then depending on the results of that, whether it's positive or 0 or negative, will tell you if it has two solutions, one solution, or no real solutions. Alright, so if we look at the discriminant for this problem, we've got b squared, which would be 4, minus 4 times a, which is 1, times c, which is 2. This comes out to negative 4, so what that tells us, we have no real solutions, and it will not factor. Okay, so we say it's irreducible. So what we're going to end up with here now is a quadratic factor, and we're going to have to handle that a little bit differently than we have in the previous example. So when we split this up, when we decompose this, we're going to have a over x plus 1. That's my linear factor. But then, remember in the first video I mentioned that my numerator has to be 1 degree less. So since my second denominator is going to be x squared plus 2x plus 2, my numerator has to be a degree 1 since my denominator is degree 2. So we're going to have a bx plus c. And then if we had another quadratic factor, we would have a dx plus e, or whatever variables you wanted to use. So now we're going to work with this. We're going to use the same method that we did before. So we're going to multiply through by the common denominator. So I'm going to multiply through by x plus 1 times x squared plus 2x plus 2. Ran out of a little room here. So what we get is 3x squared plus 2x plus 1. And then my a is going to be multiplied by x squared plus 2x plus 2, because the x plus 1s are going to cancel. And then my bx plus c will be multiplied by x plus 1, because the quadratics will cancel out when I distribute that common denominator. Alright, so again, just looking for convenient values for x to plug in. So let's start with negative 1. So x is equal to negative 1, and then we'll plug that in and see what we get. So I end up with 2 on the left when I plug in negative 1. And negative 1 over here is going to make this 0. So 0 times this term just is 0. And when I plug negative 1 in here, it turns out to be 1. So I get that a is equal to 2. Feel free to pause if you want to go check that arithmetic there. And then I'll plug in x is equal to 0. So when I plug in 0 on the left, I get 1. And then this is going to be 2 for a. And then when I plug 0 in here, I'll get 2. Plus 0 in for x. Over here, this term is all going to go away. Let's see, hang on a second there. 0 in, this b is just the b is going to cancel, so I'm going to be left with c times 1. And if we solve this, we'll get that c is negative 3. And then let's just use x equals 1. That'll be a convenient value there. And we should get 6 on the left. And this will give us 10 when I substitute in 2 for a and 1 for x, plus 1 here, and c was -3, so that'll be b minus 3 times 2, substituting in 1 for x. And again, solving this for b, we should get that b is equal to 1. So we've got a and c and b, and we can go ahead and substitute those in. So I end up with 2 over x plus 1 plus 1x minus 3 over x squared plus 2x plus 2 as our final answer. So similar process, you just have to be careful that when you have these quadratic denominators, that your degree of the numerator is linear, degree 1 instead of degree 0. So here's a problem for you to give it a try. Feel free to pause the video, and when you restart, the solution will be up there for you so you can check your answer. And go ahead and pause now. Here's our solution for the second problem using irreducible factors, irreducible quadratic factors. So hopefully you got -3/2 for a, and 1/2 for c, and 3/2 for b. And then when we go ahead and substitute everything in, this is what we'll get for our two fractions. You know, just be real careful when you're plugging in these different values for x, so you don't make a silly arithmetic mistake. And then if you had any questions, make sure you go ahead and ask. We do have one more type of problem that we're going to do if the degree of the numerator is greater than the degree of the denominator. We'll have to figure out what to do with that as well. I don't know if you noticed, but all the problems we did here, the degree of the numerator was less than the degree of the denominator. So for now, you've got everything you need to start practicing these. Again, this is a skill that's going to be important for you when you get to calculus next year. So make sure you're getting help when you need it, and we'll see you next time.